4 points on the unit circle that we look at are the 45-degree family, and 45 degrees in radians is pi over 4. And this is called the 45-degree family because every single one of these points has a reference angle of 45 degrees. So we can start with our degrees. And we know this is 45 degrees. And if the reference angle was 45, then this angle will be 180 minus 45. This one will be 180 plus 45. And 360 minus 45. We go to radians. And in radians, 45 degrees is pi over 4. And in the same sense that we found 135 by doing 180 minus 45, to find this angle, we have to do
all grade 10 French and English students, as well as their teachers, please proceed to the gym. That's all grade 10 students, both French and English, as well as their teachers, please proceed to the gym.
So you would do pi minus pi over 4, but then you have to remember, how do I subtract fractions? I need a common denominator, so I change pi to 4 pi over 4. 4 pi over 4 minus 1 pi over 4 will give me 3 pi over 4 for that angle. Same thing in quadrant 3. You would do pi plus pi over 4, or 4 pi over 4 plus pi over 4, and you get 5 pi over 4. And in quadrant 4, in degrees, we would go 360 degrees minus 45 to find the 315. So we would have to go 2 pi minus pi over 4. 2 pi is, what is this? 8 pi over 4. So I get a common denominator. Subtracting that would give me 7 pi over 4. So the 45 degree, we can write all the angles in degrees and all the angles in radians. Now, if we make, all right, so now we need to figure out how are we going to find these coordinates, the x coordinate and the y coordinate for these points without a calculator. And the idea is, if we imagine drawing one of the triangles, so in the space that you have, you can imagine going back to our x-axis and making a triangle with 45 degrees with 90. And we have to be able to think about this triangle and figure out sine, cosine, tan just using this triangle. And how can we do that without a calculator? Well, one of the things that we're going to notice with this triangle is you can tell me what the other angle is, right? This is 90, this is 45, triangles add up to 180. We would figure out that this other angle is also 45, which then gives us a realization of what kind of triangle this is. This is a special kind of right triangle. What do we call a triangle when both the angles are the same? Remember its name? Starts with an I. Isosceles, remember that? So an isosceles triangle has both angles the same, and if it has both angles the same, we're also going to know that both of these sides would be the same. And that's going to be the key. As soon as you know that both of those sides are going to be the same, we can arbitrarily pick any number we would like for one of these sides, and you would know the other side would have to be the same. For ease of mathematics, I'm going to pick right now just 1. If this side is 1, then this side is 1. And if you have 2 sides on a right angled triangle, you can always find the third side by just doing a squared plus b squared equals c squared. So if I do 1 squared plus 1 squared, that would be 2. This side here will be the square root of 2. And now that we have that triangle, you can figure out what sine of 45 degrees is without your calculator. Sine is opposite over hypotenuse. It'll be 1 over root 2. And where this one, we often will, just like we did in grade 11, we will rationalize the denominator. So you have a choice. You can write sine of 45 as 1 over root 2, or it's the same as root 2 over 2. And from that same triangle, we would know that cos of 45 degrees is also root 2 over 2, and tan of 45 degrees is 1 over 1, which is 1. And if you'd picked different numbers, like if you'd chosen to make the side 2, then the other side would be 2. Doing a squared plus b squared equals c squared, you would get a different hypotenuse. But I will tell you that the ratios will always simplify to this. I think it's easiest to see with tan. If I pick 2 and 2, can you see that tan would have been 2 over 2 would still be 1? If you picked 8 and 8, tan would have been 8 over 8, and it would still be 1. So any values you choose, it'll work out in the end. Choosing 1 is nice because most of these are almost completely simplified already. Now what this triangle lets us do is it lets us go back to our coordinates, and since the x-coordinate is cos and the y-coordinate is sine, those will be both root 2 over 2, root 2 over 2. And once you know one coordinate, when you go across to this other coordinate, now my x-coordinate will be negative and my y-coordinate will be positive, but the values will be exactly the same. In quadrant 3, they would both be negative, and in quadrant 4, just your y-coordinate would be negative. And we can label all of our tangents. So tan of pi over 4, it's equal to 1. Tangent of 3 pi over 4, well, it will also equal 1, but because of the cast rule, tan is negative in quadrant 2. Also, if you think of tan as sine divided by cos, that's one of our big ideas, you get positive root 2 over 2 divided by negative root 2 over 2, you will get a negative 1. And in quadrant 3, it'll be positive 1 again. Again, according to your cast rule, tangent is positive in quadrant 3. But also, since tangent is sine divided by cos, you have a negative number divided by a negative number, you will get a positive number. And finally, in quadrant 4, we will get negative 1. Do you remember who was the last volunteer last class? Who answered the last question? Was Denon? Okay. Denon, you get to pick the first volunteer now. I'm going to ask you to do cos of 135 degrees. Who are you picking, Denon? James. Cos of 135 degrees. Negative root 2 over 2. Perfect. How about sine of 5 pi over 4? James, who are you going to pick? Negative root 2 over 2. Okay, next we're going to do cos of 315 degrees.
Addison.
Positive square root 2 over 2. You guys catching this?
Yeah.
Yeah? No? Okay.
A little bit.
So, on our legend, the coordinates, our big idea says the coordinates are cos comma sine. So when Addison solved cos of 315 degrees, she found 315 degrees, went to the coordinates, and then it's either going to be the negative or the positive, but because I said cos is the x coordinate, it's positive root 2 over 2. If I had said sine of 315 degrees, then you would go to your y coordinate, and sine of 315 degrees is negative root 2 over 2. So one of the things you're going to do for mental math is you're going to have to, when you hear an angle, like sine of 225 degrees, you're going to have to connect right away that 225 degrees has a reference angle of 45 degrees. I know it's part of this family. So I know that sine is going to be root 2 over 2, and I have to decide whether it's going to be positive or negative. In quadrant 3, sine is negative. Sine of 225 degrees would be negative root 2 over 2. Okay, turn the page. 2 more families to go. Pi over 6 family. The 30-degree family. Draw your dots. All of those dots have a reference angle of 30 degrees. All of them have a reference angle of pi over 6. I'm going to give you a head start on them. With degrees, 30 degrees, and with radians, pi over 6. You have to fill in the other ones. What are the other angles in degrees? What are the other angles in radians? All right, let's see how you did. Did you get in degrees 150 degrees, 210 degrees, and 330 degrees? How did you do in radians? Did you get 5 pi over 6, 7 pi over 6, and 11 pi over 6? Any questions on any of those? And now, in this space in between the 30 and the 60-degree family, there's actually one triangle for 30 degrees and 60 degrees. Because if I draw a right angled triangle, and I'm going to label the top angle as 30 degrees, that'll automatically make the other angle 60 degrees. And when we drew our special triangle for 45 degrees, we got an isosceles triangle, which let us label 2 sides. This time, we've got a 90-degree angle and we've got a 30-degree and a 60-degree. And there's a name for this triangle as well, right? If we think about special triangles, isosceles triangle, equilateral triangle, then they gave a name to all the other triangles that aren't anything special. And they're called scalene triangles. Probably, maybe you've heard of it, maybe not. Scalene just means all your angles are different, all your sides are different. In fact, they're not very special in any way. So this triangle right now is feeling a little sad. They're feeling like I'm not very special. They're walking down the street, their head is kind of down, going, I'm not very special. And they come across another triangle just like them. You know, like hi, you know, triangles when they meet each other, go through greetings and talk to each other. And the one was like, oh, you're just like me. Yeah, we're not very special. And they're like, well, we want to be friends. And it's okay. This makes sense that since we're both feeling kind of similar, not the same, they decide to become friends. And if we took another triangle exactly like this one and drew it on the other side, this would still be 90, this would still be 60, and this would be 30. And when they get together, something special. If we put both of those triangles together to create one big triangle, that big triangle now has all the sides exactly the same and all the angles exactly the same. In fact, putting those together, we make an equilateral triangle. And this would allow us to pick any side length, right? Any side length that I pick here will be all the sides together. I can pick any number I want. Now the nice number mathematically will be to say this is 2 because this breaks this up nicely to 1 and 1, and this side is 2. And once I've done that, I'm like, oh, I can do a squared plus b squared equals c squared and find out that this height will be the square root of 3. Because 2 squared is 4, 1 squared is 1, 4 minus 1 would be 3, and we get the square root of 3. And what this lets us do is we can now do sine of 30 degrees, cos of 30 degrees, tan of 30 degrees, in addition to sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. So sine would be opposite over hypotenuse. This will be 1 over 2. Cos will be adjacent over hypotenuse. This will be the square root of 3 over 2. And tangent would be opposite over adjacent, 1 over root 3. Or, if you rationalize, you will get root 3 over 3. So I would say more often you see the answer rationalized as root 3 over 3. But if you wrote it either way, it would be fine. Same thing, we could go to sine of 60. Look at 60 degrees opposite over hypotenuse, cos of 60 adjacent over hypotenuse, and tan of 60 opposite over adjacent. And now this special triangle lets us label our points. Can I scroll up? Everybody got these down? Almost. So, when I go to label these points, I remember that my x is cos theta, my y is sine theta. So when I look at cos of 30 degrees, I get root 3 over 2, and sine of 30 degrees is 1 over root 2. And once you know your coordinates in quadrant 1, all of your other coordinates are going to be exactly the same. The only difference is whether what's positive and what's negative. Now, if I go to quadrant 2, my x coordinate will be negative. my y-coordinate positive. Quadrant 3, they'll both be negative. And quadrant 4, just your y-coordinate will be negative. Now you have to have this whole thing memorized in the end, but now we're starting to see some patterns. Once you know quadrant 1, you're going to know all the other quadrants. And when I get to tangent of pi over 6, that's root 3 over 3. Then tangent of 5 pi over 6 will be negative root 3 over 3. Tangent of 7 pi over 6, back to positive, and tangent of 11 pi over 6 is negative again. Okay, we were at Addison, so cos of 7 pi over 6 is going to be the next question, and Addison is going to pick someone. Yes. Cos 7 pi over 6, negative square root of 3 over 2. Next, sine of 150 degrees. Okay. That 1/2. All right. How about cos of 5 pi over 6? I'll add a little bit of thinking to this next one. I want you to do sine of negative pi over 6. Sine of negative pi over 6. James. Negative 1/2. So when I say negative pi over 6, that's going in the opposite direction. It has that same reference angle. It's going to end and be coterminal. Remember that word coterminal? Two angles that end in the same spot. Negative pi over 6 would be coterminal with 11 pi over 6. And so the point is still here, and sine is your y-coordinate, so you get negative 1/2. All right, let's go to a pi over 3 family. Draw our dots. 60 degrees. Pi over 3. And the coordinates for quadrant 1 are 1/2 root 3 over 2. And I'll give you a head start to do the rest of the degrees, the rest of the radians, and the rest of the coordinates. let's see how he did. Degrees, did you get 120 degrees, 240 degrees, and 300 degrees? Radians, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And coordinates. Coordinates stay the same, just the negatives change. And then finally, you can look at your special triangle, and we can also write out tan of pi over 3 is root 3. Tan of 2 pi over 3, negative root 3. Tan of 4 pi over 3, positive root 3, and tan of 5 pi over 3 to be negative root 3. And these are all the things on the unit circle that we have to know without our calculator. In other words, this whole thing has to be memorized, and we will have a quiz on it next week, Wednesday. And this is the only quiz that is a little bit different than normal. First of all, I just handed it out to you. The quiz that I just handed out is exactly the quiz you are going to write on Wednesday. In other words, on Wednesday, you get this blank paper. You will have to fill in all of the spaces. One of the things that I recommend is color coding. So here I have all my pi over 4 family in green, all of my pi over 3 family in yellow, and all of my pi over 6 family in blue. Because if you know something about it in quadrant 1, you can say the same coordinates all the way through, right? And just change positive or negative. You can figure out, they all have the same reference angle, so you can figure out the degrees and radians easier. So you're going to have to fill out this entire thing, right? There it is. All of the information from your 4 families put together in one. The other thing that's going to be different about this quiz compared to other quizzes is this quiz you are required to get 100%. If you make one mistake, you have a 0. But you have unlimited attempts in 1 week to get 100%. Lots of people get 100% actually on the first chance. Why? Well, once you realize the patterns that happen, it's not too bad. If you tried to memorize this all as 100 individual things, it would be hard. But with the patterns, it's not too bad. And also, the first time we do the quiz, it's in class. Then, if you don't get 100%, then you have to come back at lunch or outside of class to have all of your other attempts. And some people try 3 times and 4 times. They do everything and leave one thing blank. Oh, or forget a negative. So it is also pretty easy to make one little mistake. So you will be required to get 100% on this for Wednesday. And you just have to transfer all the information from your page with the 4 different families. One side is for you to put stuff on. The other side, you have another copy, so you have one to practice. We'll talk about some strategies on Tuesday of next week for how to do this best. And the other thing that we're going to be doing with our unit circles is a project. And, whoa, that's not what I wanted. Here we go. So I'm going to show you some examples of projects. And I recently had to clean up. So you would have, prior to today, seen some projects that were up on the walls and some that were on the side there of projects that people have done in the past. So this is the idea. You are going to get a paper plate and you are going to design a unit circle on the paper plate using nice color coding. Put all of the angles, all of the radians, all of the coordinates, and all of the tangent on the paper plate. This one, as you can see as an example, they've color-coded things. They made the inner circle, the unit circle, and then with their color coding, they made things really neat all the way around the outside. One thing I like about this one is that with their neatness, it's really easy to see the coordinates. The radians are always in the same spot. The degrees are always in the same spot. It's really easy to get information off of your equipment. So one of the things you want to do, because you will be using this in this unit and the next unit, is that you want to be able to grab your pie plate and get information off of it quickly. Some creativity. This one made it into a spider web. Okay. They have their radians around the outside. They've got it color-coded nicely, and they put all their radians and degrees on the inside. They also put decimals of pi all the way around the outside. They've got like 300 decimals of pi around the outside. Yeah. Oh, this one was made to look like maybe a cherry pie, maybe it's painted it to make it look like a pie. Again, they've got all of their things in certain spots, in certain places. This person separated the 4 quadrants into 4 different seasons. And what's crazy about this one is they put leaves and snowflakes, and if you look closely, they actually sewed the leaves on the paper plate with a sewing machine. Okay, so at this moment you're probably thinking, why are these people crazy? Why did they put so much time and effort into these? Well, there's a little bit of a competition, okay? And the competition works like this. After all the pie plates are submitted, I spread them out. I get random teachers to come by. They pick their top 5. If they pick yours as one of their top 5, you get 5 points. If you get a 2nd place, you get 4 points. 3rd place, 3 points. 4th place, 2 points. 5th place gets 1 point. And I do this with a bunch of teachers. I add up all the points, and the top 3 in the class get a bonus mark on their next. So that's the competition part, and why some of these have been a little bit crazy. So we're going to start this activity, get it ready for you. I will hand out a paper plate to everyone. Take one, pass it back. If you screw up on your paper plate, you can get another one for a donation, minimum donation 25 cents, whatever the next charity that the school is going towards. So, the first thing we are going to do with our paper plates, and the first place that you can screw up if you're not careful, is carefully folding in half. Now, when you carefully fold something in half with a paper plate, you want the edges to match up. Yeah, it's a little bit stiff, yes. You want the edges to match up, you want to hold it tight, and while you're holding it tight, press it down so that the edges of your circle match up. And once it's matched up, you can flatten it out pretty good. And you'll want to be holding it while you flatten it, because it could shift and not be perfectly folded in half. Okay? Secondly, the second fold is harder than the first fold. You folded it in half, pressed it down. Now when you fold it in half again, not only does it have to match up perfectly, but the lines from your first fold have to match up perfectly. Hold that spot tight and fold it in half. This will create perfectly 4 quadrants. I'll give you the instructions for you so that you have them. Then what you're going to do on your own, right, these things that you folded, they become your axes family. So I suggest maybe you make your axes family black. You can decide whatever colors you want. There's some creativity involved in this project. So you want to maybe do some planning. You're going to label your x-axis and y-axis, and then you're going to measure, and if you need to, you can borrow a protractor. If you don't have your own, you can borrow one from me and get it back. I'll just need to know who's grabbing them. You're going to measure 30 degrees on here. Draw your 30 degrees family. Measure reference angles of 45. Draw your 45-degree family. When you draw them, they will be straight lines that go all the way through. So you can use a ruler. Right, here's one. They drew their lines first with dark lines all the way through. Okay. And the suggestion that each family have their own color. This person decided not to draw the lines, they just did the dots because of their artistic thing that they decided. So you have some creativity, some artistic choices. This person decided to do all black because of what they were drawing. Okay? But a suggestion is having each family having their own color. Then everything that is on your quiz has to go onto your pie plate. So we're going to put all of the degrees, all of the radians, all of the coordinates, all of the tangents. And here too you have some different choices. Like the first one that I showed you, they color-coded things as purple Dark purple was all the radians. Other purple was all degrees. Coordinates were all green. Tangent was all teal, so that they could find things quickly. Sometimes people choose, like for example, on the spiderweb one, they decided that their pi over 6 family was all going to be red, so they made all the degrees red, all the tangent red, all the coordinates red, everything red for that, and they just spaced things out on their pi plate so that they could figure things out easily that way. So you have some choice here, but you're going to put your entire quiz goes on the pi plate. And for your exam, you have to have this memorized. For this unit, you have to have it memorized. For your next unit, we use it a lot, and you're allowed to bring in your official pi plate to that test. So you want to make it so that the answers are right on there. You also want to make it so that you can find the answers quickly and easily. Then on the back, you will have a legend explaining your color coding, what colors you used and why for each thing, and you will have to give your pi plate a creative name. So this one, the person called it pie face. In fact, if you look on the back, you can see that they painted a blueberry pie with a piece taken out. Can you see that? Okay. Some of them have creative, like dad joke names. Here's the creative. Anybody guess what this one was called? This one was called spider web, spelled with a pi symbol instead of spider. It's pi web. Okay. All right. Oh yeah. You see a snake on there? Any guesses what this one was called? Any idea? The python. Okay. Oh. Any guesses? Octopi. Northern pipe. Sometimes there are fails with the name. I think this is a great name, fail. Okay, there's the sun and planets. This one was called Pilanix. I think that was a bit of a name fail. Tried to use pi. And sometimes the name has nothing to do with, it just has to do with what they have. There's one here that is, what? They like purple. This one's called the purple pie plate. So it's purple. Whatever you want. Ooh. Pumpkin. Whatever you want. Here's Gary. Gary the snail. That was the name of this one. Nothing to do with pie. It's perfectly fine. So you will have to be creative, come up with a name, have some fun. There are some examples. And let's make the pie plate do not on this Monday, but the following. Because this Monday, this weekend, you have your test on Monday, right? Test is counting for a lot of marks. Should be focusing on studying for that test. But so that you have a weekend to work on this if you want, we'll do it a week from Monday. That is what date? Someone have a calendar? The next Monday is February 27th. The following Monday is March. What is today? Yes. Following Monday would be March 6th. There we go. That is when your pie plates will be due.